Hi, I'm Andrew Armstrong and welcome to the Back Office Teardown Lab. You might have seen these. These are, I think they're a Lumie, yes, a Lumie lamp, and they're one of those lamps that supposedly slowly gets brighter. It's like an alarm clock, but an alarm clock with light. And an annoying beep if you don't wake up eventually. Problem with this one is I've plugged it in and it doesn't work. So I swapped out the fuse and it still didn't work. I swapped out the bulb, which was dead, and that didn't work. The fuse was blown, as was the bulb. So I'm just doing one quick test before I go any further, because sometimes it is the obvious thing. Now this is in a Euro to UK fuse adapter. Wow, I just realised you could plug this in. I reckon you could plug this in open and then touch that, and that would give you a bad day. I've never noticed that in this design. But looking at it, I don't have any reason to believe that it's not working. If you don't know, these are often supplied with UK goods because it's mandatory that they're provided with a fused plug, and that is a pretty good solution, and I've never actually seen one break. I'm just going to plug it in the end just to double check. Yep, the clock is still dead. So we're going to dismantle this and finally a teardown. So we'll just pop off that. That's the diffuser. Good quality plastic. Now these things were incredibly expensive when they were new. I think they retailed something like £60 or maybe even more. But I've always picked mine up at car boot sales because people just flog them for next to nothing. So that's a top tip for you. And another top tip is you're going to need a Phillips screwdriver to get in, and I need to go find one. Screwdriver obtained. So you've got some instructions on the bottom, which is quite nice, isn't it? They're saying it's the Lumie Body Clock Sunray 100. Patent pending. Always with the patent pending. I'm just reading some of these instructions. It had one of those multi-purpose buttons where you hold down one of the buttons and it can set the alarm, or it can set the time, or it can set the something. All I know is every time you'd lose power, it would forget everything and you'd have to start again. I don't know why. I do know. I was going to say, I don't know why they don't put a bit of flash memory in these things to remember your settings. Because it's expensive. So let's get all the screws out. Let's see what we can see. Of course, if you've got one at home and you're going to mess around with the mains, be aware that you could electrocute yourself, so be careful. This is fascinating. Oh, lost me knob. It's fascinating because there's something attached here, and I think that's a temperature sensor, which is kind of cool. Makes sense though, right? You want to detect the temperature of the housing. Anyway, let's pop that off so we can get a bit more room. So you can see you've got a screen here at an angle. It's an angled screen. There's a button in there. There's a small PCB that controls these buttons, so I'm going to pop that out so we get a little bit more room to play with. We've got the mains cable coming in left, and there is indeed an onboard fuse. Let me have a look at that. But before we do, let's just have a little overview. It's trying to pull itself off the desk. I'm going to kind of hold it down. You've got an Atmel 8089C2051, so that's your pretty much microcontroller. A buzzer, that's your alarm buzzer. And just a few more bits and bobs. There's more components in it than I think you'd normally want to need, but it's a reasonably high quality power supply. Look at that. You've got your little choke and your adapter. So it doesn't come with a this is a modern thing now. It wouldn't come with a mains plug, I'm sure. It would just come with an AC adapter. And there's your opto isolator in there for the feedback for the power supply. Is that a full wave bridge rectifier in there? And there's going to be some sort of triac, which is probably what that is, although no, that's a L7805, that's a 5-volt regulator, so that's the power supply for that. That must be the triac that's controlling the dimming. Anyway, you don't need to know how it works, do you? You just need to know how to fix it. So let's try this fuse. And what can we see? I'm going to let go of it, don't fall off the desk. So to test a fuse, I can see it's blown anyway, but let's pretend we're going through the motions. Get your multimeter and set it to your ohms meter or your continuity. They're pretty much the same thing. It's just when you get over a certain amount, it'll beep. Basically, if you've got some resistance, when it says OL, it means overload. It just means there's nothing. It's not measuring anything at all, which is what you'll measure like now if it's a dead fuse. But if it was a good fuse, it would be something a little bit more like that, and it would beep. So get your multimeter and test it that way, see if it does anything, then touch your probes together, make sure everything, and that's the sanity check to make sure that your meter's working. So let's see, if you look very closely, you can sometimes read off the value. And yep, I've got a value off it. So you see on the bottom there, I'm going to rotate it slowly. 500 MA, 500 milliamps. So that's a pretty teeny value. I'm going to have a little search in me box to see if I've got another one of these. Hopefully I have. Got me dirty tin of fuses. I think it came, this was a little one of those things that had a little bottle of scotch in it, and now it's a box of fuses. And you can see these are your standard house fuses. Now they're going to be way too high for anything you're likely to going to do. So they in the UK come 3 amps, 5 amps, 13 amps. I don't know if there's a 1 amp. You can get fuse wire. Sometimes I use fuse wire for things. And then you can see in here I've got a few loose fuses, and there's a couple of small glass fuses, and there's a 500 milliamp right away, which I can see, which is great. We know that's going to do the trick. But I am kind of curious to see what I've got in these other bags. So this is another, it just says fuse on it. And those are some mystery fuses, and they're also glass fuses, so we'll shove that away. And then I've got one floating in this little Ziploc type baggie. Let's see what value that is. 250 volts, yes, we know that much. I think that's 1 amp. That's no good. That's twice as much as we need. So I'll get the 500 milliamps out. It's just nice to use up a random fuse if I could, but no, I'll use up one of my marked fuses. So we'll plop that out of the thing and put it in the thing. Put it in the fuse holder. Now I'm going to do what you shouldn't do, and that's plug this all back in before putting the lid on, because that's the bit it could be considered dangerous. And whatever you do, don't put your hands on this part while you plug it in, because that would be suicide. So I'm just going to plug it in. I'm covering my face, and it's come on, and the clock thing is flashing. Looks a bit dim, but that's fine. It's probably just because I've got insanely bright lights in the back office. So we can throw away the old fuse that doesn't work. And pop the lid on. I have unplugged it, by the way. Don't worry, I have unplugged it. So something I have done in the past, which is a little bit naughty, but I'd like you to comment on its naughtiness factor, is that fuses are made out of basically their wire. That is exactly all they are, really. They're nothing but a piece of wire, and of a known rating. So that means they've sort of been tested somehow through the years, and there's a chart more or less that tells you what grade of wire, what thickness, what gauge, what AWG equates to what fusing capacity. So also that's related to material. So if you have a bit of I don't know, nickel wire, for example, that's 0.1 millimeters, that will be the equivalent of a X amps, or that will be able to handle X amps of fusing. So in the past, when I haven't had the appropriate thing, and I have happened to have wire, I have made, well, not made the fuse, basically repaired the fuse by opening up the glass of the fuse and soldering in a new bit of wire, or a couple of pieces of wire. So it depends. If I needed to double up on the loading, the capacity, I would double up on the wire. Sorry, I thought I lost a screw there, like a madman. And there you go, put it all in and it works. And you've seen that when I've actually used, I've used the same technique when I've repaired the DS's, when I've needed a surface mount fuse and I haven't had that, and I've tried to get an appropriate thread-like piece of wire. Sometimes I use that very fine copper winding wire you use for coils and things. But yeah, what's your view on that? Do you think it's sailing close to the wind, or should I always buy the right fuse? Because I kind of feel I'm applying the science and the engineering behind it. And, you know, I'm kind of trying to understand what I do. I think I do understand how a fuse works. So I'm really just taking the consumer step out of it and doing it myself. So yeah, let me know your views. So that's the Lumie light doing what it does best, which is illuminating. And yeah, it's got this thing. I'll just show you. When you set it and you kind of the kids go to bed, it does this thing where it dims down slowly, so they go to sleepy land. And then in the morning, just before the alarm goes off, it goes bright. Helps you get out of a winter rut, allegedly. Hope that's of some use to you. Please like, share, subscribe if you're that way inclined. And if you are interested into seeing what's inside this FPGA, look out for my future video on it. As ever, thanks for watching.